So this is the last presentation from our B group. So I'd like to invite Mr. Rob Coggan, who's our Australian panel convener for protection and automation.
G'day everyone. My name's Rob Coggan. I'm the convener for the Australian B5 panel. Here's a bit of a summary about what we've seen in 2025. So realistically, the B5 mission is to facilitate and promote advancements in exchange of information, expansive knowledge in terms of protection, metering, automation, control, and fault locating. So we take part in a lot of measuring the power system, how we take, and we care about what the power system event we're trying to measure is, what the details about how to make the measurement, and more about how we publish that information, share it on the digital systems inside a substation, and then take action. And that action is now moving from inside the substation to wide area systems as well. So we spent a bit of time thinking about functional integration of devices. We're looking more at virtualization of protection is becoming a very big theme for us. So moving from discrete relays, with a lot of functions in it, to thinking more about centralised compute platforms. So separating those activities out from measurement to decision making. So we look at a lot of exploring of new technologies to do that. We're looking at new network requirements. So we're trying to cover off the design application of digital systems. And as the network is evolving, with the different types of generation, the different types of loads, and the rapid increase and change in the network, we're trying to make sure that we can measure and make the right decisions at the right time. And a big one for us at the moment is the system-wide protection and control scheme. So, as we're trying to leverage more capability out of the power system, we're using up some of the overhead that was traditionally included in that power system, and we're doing that by having fast-acting control systems that can help to move loads around, deload parts of the network, or provide intervening action if we have an event on the network that needs to be interrupted. In our space at the moment, so we've got new working groups this year. So we've got B587, which is digital transformation of protection, automation and control systems, expanding the application of 61850, implementing an implementation guide for fully digital 61850 based protection systems. And then we're looking at protection redundancy and backup for modern power systems. The protection redundancy and backup is an evolution. So we've written that technical brochure. We've had that working group in the past, but now we're looking at, with the different types of technology, with the changing of fault levels, we need to re-prosecute that one and try and, understand whether some of the historical principles that we've applied are still valid. So the focus areas in this are, improving our methods to deploy 61850 base substations. Tools, data management and communication, so a lot of the 61850 systems are built, on tools, and, a lot of the tooling in a perfect world means that, things are interoperable and, information can be exchanged. There's been a lot of stuff in the past that's been done around Excel spreadsheets, so, moving it from the Excel spreadsheet engineered into proper software tools is important for us. And then, as I said, still exploring the backup protection challenges. Backup protection is really handy when you need it, but it doesn't get a lot of attention until it either goes wrong or saves you. So this year we took part in the Osaka Colloquium. So that was a B5 focused event. There was 48 papers presented at that across 3 thematic groups, with about 200 delegates, and a modest sized vendor display or vendor presentation. Showcase there. The themes there, so we spent some time going through 61850 based interoperability of different IEDs, manufacturers and technologies. So I think that the conversation we've always had in our space is, interoperability has been a big talking point, but I think that we've historically probably aspired to interchangeability, and interoperability has been the probably the term that's been sort of messed up a little bit in that. So, trying to, make sure that, devices play well from time sync perspectives, and, the data models, and that has been important. Looking at the protection control system lifecycle and performance management and longevity, one of the concerns for us is that the systems that we put in the past, we would put them in for, a 20+ year life cycle, so 20, sometimes we're getting 40+ years out of some of these electromechanical devices. Now we're starting to put devices in that might have a 20, 25-year life cycle and possibly even shorter than that. And we're putting a lot more devices on the network as well, so we're duplicating our protections, we're putting more endpoints on our network, more customer connections. So we're trying to work out, exactly how we manage these things, with the limited resources and the increasing complexity. And then sharing some best practices on revised principles by enabling that you can enable in modern protection devices. So, with the devices we've got, they're multifunction. So, what other features can you enable as part of putting those devices in? So on the picture there, we've got one of our Australian panel members, Tariq, who's presenting his poster on it's basically config management, a configuration management system that he built as part of his work at Endeavour. This year, the key issues for Australian Panel B5. This has come out over a number of forums, so the panel meeting, the general discussions, and even from the CPAC conference that we've just had. So we've got things like cybersecurity. So, we've got increasing numbers of devices that we put on the network. Most devices now have some sort of communications capability. And, with that, even trying to go down the path of, can you air gap it, can you separate it? There's a lot of value when we want to use these devices across different networks, across different substations. So, there's a part there where, having the communications on these devices is unavoidable and adds a lot of advantages, but we need to be able to work out how to secure them. And there's complexity issues that we've got. So we've got, with the cybersecurity, as we're trying to make them more secure, they're more complex, and fundamentally what we build are safety-related systems. So we don't want to make it so that they're that complex that they don't operate, from something that we didn't foresee when we were building them. Modelling for us, we really do struggle in our space about modelling, the new types of generation that are coming on the network, any of the technology that's moved away from, predominantly being physics-based to, some of it's more software and code-based is a real challenge for us. And one of the things from a protection perspective, we worry about we can model it, but then what happens after it's been modelled, so is there a firmware update or something else that can completely change how that piece of equipment operates? So there's a little bit in our space about trying to work away from how do we think the device will operate, because to how can we operate, even if it doesn't operate the way we expect, and that's quite a challenge for us. Wide area systems, we touched on that earlier, so there's growing needs for wide area systems. We are trying to get more capacity out of the network that we have. We've got lots of connections, and we do want to load those networks up and take full advantage of them. But as we do that, we unlock capacity, but we probably do increase some of the risks associated with it. So, obviously we've got the network out there that, you can now have an event where if you've got a wide area control scheme, the wide area control scheme can cause an outage, by failure of the control scheme. So you need to start considering those aspects. And then fully digital substations, so, tools and processes to do that, documentation and training. And then starting to think about, moving away from, we've got digital substations full of IEDs to, we've now got centralised and virtualised protection. And we need to start thinking about what skills we can do there, because it starts to move away from, you're putting in a box and you're building something to, you're now probably configuring servers with hypervisors, and you're starting to think about all the redundancies around that. I won't spend too long on this slide here. So this was a big part of our world this year. So each 2 years we hold the CPAC conference. And I've got a similar slide in a minute for the next session. So I'll quickly run through that. But 35 presentations across 2 days, and we had a number of different themes. Big thing is digital systems are fast becoming the norm. We need to make sure we sort of position ourselves to be able to take advantage of that. Centralisation, virtualisation, growing areas of interest and opportunity. There's a lot of conversations around some of the virtualisation and centralised protections in the sessions. And then, with the changing technologies, we need to, some of the existing issues still exist. So we still have power systems, we still have power system faults, we still have events that we need to consider. So we need to make sure that we don't lose focus of the history. This year, so the highlights, actually, if I stand here, it's probably in the same spot for that photo that happened in May. So we had our Australian B5 panel meeting in this building here in Adelaide, looking out over the same views. And then obviously we had Tariq, taking part in the presentations at Osaka. I think just beyond that, probably just a few things I didn't put on the slides because that was sort of a little more forward-looking than backwards-looking. So in Paris, we're going to start talking about knowledge management. So our preferential subjects this year will be around knowledge management and then protection and control systems in networks with unconventional sources. And we're starting to consider working groups beyond the ones we've currently got, and we'll be starting to look at monitoring and diagnostic of protection control systems in digital substations. Best practices and challenges related to islanding protections. So, we are obviously concerned that our network can have islands. Some islands we're happy to have. So, typically, the uncontrolled islands are a problem, so we're looking to see how we can protect that. Guidelines for commissioning and testing fully digital substations will be a big one for us as well. Beyond that, when we start to look to 2027, we'll be starting looking at the use of AI. And we're already talking about studying the impacts of renewable energy integration into system integrity protection systems, so the wide area systems back out there. So it's renewable generation, wide area control systems, and potentially the AI will be our threads going forward for the next couple of years. Cool. That's it.